The lesson for the second semester for your academic calendar consists of 2 chapters. The first is electrolyte solution and redox concept, and then the second is stoichiometry. In this part, we are talking about the first chapter, part A, electrolytes, non-electrolytes. Electrolyte is something common in our daily life. For example, you may often drink coconut water, milk, watermelon water, smoothies, electrolyte-infused waters, electrolyte tablets, sport drinks, and Pedialyte. So, what is meant by electrolyte? Electrolytes are solutions that can conduct electricity, and non-electrolytes solutions that cannot conduct electricity. When you heard solution, remember that solution is a mixture, consists of solute, something that dissolves in the mixture, and solvent, something that dissolves the solute. For example, infused solution that contain iron, sodium, potassium, calcium, magnesium, chlorine, bicarbonate, hydrogen phosphate, sulfate, and protein. For the solvent, we usually use water. For the solute, could be covalent compounds or ionic compounds. For covalent, the electrolytes is the polar. For example, acid. For ionic compounds, can be salts or bases. Once again, I want to emphasize electrolyte solutions can be acids, bases, or salt solution. Strong electrolytes can be strong acids, strong bases, or soluble salts. Weak electrolytes could be weak acids, weak bases, or insoluble salts. Here we have some examples of strong electrolytes, weak electrolytes, and non-electrolytes. For strong electrolytes, for example, HCl, HBr, Hi, HNO3, HClO4, H2SO4, LiOH, NaOH, KOH, RbOH, CSOH, barium hydroxide, strontium hydroxide, and calcium hydroxide. For weak electrolytes, CH3COOH or acetic acid, HF, HNO2 nitrous acid, and H3 ammonia and water. For non-electrolyte, NH2 times 2CO or urea, CH3OH methanol, C2H5OH or ethanol, C6H12O6 or glucose, and C12H22O11 or sucrose. There are two types of electrolytes. A weak electrolyte dissociates partially. A strong electrolyte dissociates completely. Weak electrolyte solutions are poor conductors. Different weak electrolytes dissociate to different extents. A strong electrolyte is present in solution almost exclusively as ions. Strong electrolyte solutions are good conductors. Weak electrolytes include weak acids and weak bases, for example, NH4OH, a few insoluble ionic compounds, and water. Strong electrolytes include strong acids, HCl, HBr, HI, HNO3, H2SO4, HClO4. Strong bases from group 1A and group 2A, and most water-soluble ionic compounds, that is salt. How to differentiate between electrolytes, strong, weak, and non-electrolytes. First, for non-electrolytes, there is no ion. The bulb is off when we test with electrolyte tester. For weak electrolytes, there are few ions, and then the light is dim, no bubbles or a little. For strong electrolytes, the light of the bulb is bright because many ions in it. If we summarize the differences between strong electrolytes, weak electrolytes, and non-electrolytes, the first factor is beam of light. For strong electrolytes, bright. For weak electrolytes, dim. And for non-electrolytes, the light is off. Number 2, the number of bubbles of gases produced. For strong electrolytes, a lot. For weak electrolytes, few. For non-electrolytes, none of bubbles produced. Number 3, ionization degree or alpha. For strong electrolytes, almost 1 or 100% dissociates. For weak electrolytes, in between 0 and 1. For non-electrolytes, almost 0. And the example, for strong electrolytes, NaCl, H2SO4, HCl, and NaOH. For weak electrolytes, for example, CH3COOH and H3H3PO4. For non-electrolytes, for example, urea, CO and H2 times 2, glucose, and ethanol. To master the lesson, please do the exercise latihan 5.1 on page 207.